Good morning, good afternoon, good evening, ladies and gentlemen, and in today's video we're going to look at evaluation of functions by substitution, which if you find a mouthful, it is. They're actually just called composite functions. Alright, so let's take a look. So in the first example, I tell you to evaluate given f of x is equal to 5x minus 4 and g of x is equal to 2x minus 1. So as you remember from our substitution video and the evaluation video from earlier, when we say evaluate, we want you to get a final answer. So, how do I do this? Well, let's write it down. Our first step here, if I'm telling you f of g of x. So, f of g of x is the same thing as saying, well, what is g of x? G of x is 2x minus 1. Alright? And actually, let's do this in a different color, just so you can see it's different. 2x minus 1. Alright, so just like before, if I know what I'm substituting in, basically, you go into your equation, and wherever you see an x, it becomes 2x minus 1. So using my original equation, which is 5x minus 4, I've got a 5. Then I've got x. So instead of x, you put in 2x minus 1 and minus 4. Then we expand and simplify. So you've got 10x minus 5, once again. For anybody who missed it, Pokemon Go, gonna catch them all. And then minus 4, and collect your like terms. So you've got 10x minus 9. And you're done. Next up, I've got g of f of x. Now, remember, how do I know which equation from these two I'm substituting in and which one I'm substituting in? It's the letter on the outside. So if you see the f on the outside, then I'm using 5x minus 4 as the one I'm substituting into. If I see a g on the outside, then I'm using the 2x minus 1 as the one I'm substituting into. Alrighty? So once again, g of f of x is the same thing as saying g of 5x minus 4. Remember, you always want to make sure you are putting in what you are substituting first. I'm putting in different colors so you realize that's what you're putting in. Alright, equal. So you're going to start with the 2. Then there's an x there, so that x becomes 5x minus 4 minus 1 is equal to, you want to distribute, Pokemon Go, get that in there. So it's 10x minus 8 minus 1 is equal to 10x minus 9. And you're done. And lastly, what happens if there's now a number? Well, what this means is, first and foremost, you still have an f on the outside. So you're still going to have f on the inside. You have g of negative 2. Now, g of negative 2, that's like a substitution within a substitution. It's like a turducken, except in mathematics. Those of you who don't know what turduckens are, I feel so bad for you. So g of x, first of all, is 2x minus 1. So you're going to have the 2, but instead of the x, you're going to have the negative 2. All right, and minus 1. Close up my bracket. Now, before you actually substitute into the f, I would actually simplify this. So you have f. 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. So after all said and done, what am I actually substituting into f of x? Just the negative 5. So you're going to start with the 5. There's an x. That x turns into negative 5. And you're going to subtract 4. 5 times negative 5 is negative 25. Minus 4 is equal to negative 29. And that's it. That's evaluation of functions by substitution, aka composite functions. Now let's take a look at some different variety of questions so you can see this work in many different ways. Alright, let's take a look at these examples here. So once again, you're going to follow your same steps. Again, it doesn't matter what the question says in front of me. You're going to follow the exact same steps. So I'm going to put f, whatever my g of x is x minus 3. I'm going to plug it in there. So instead of x squared, this is going to become x minus 3 squared minus 9, which is equal to, you're going to do x minus 3 squared, which is, when all said and done, x squared minus 6x plus 9 minus 9. And how I did that? Well, I FOILed it. Or you could just use the perfect square formula, which is a lot quicker. So I've got x squared minus 6x plus 9 minus 9. That goes away, so I am done. Next up, we've got g of f of x. Once again, follow the same steps. And I'm actually going to be writing the steps on the bottom right now. So first step, change the function into what you are subbing. Alright, so g, what am I actually substituting? Well, I'm actually substituting x squared minus 9. Okay, and then step 2, change x into new sub. So whatever the new substitution should be, that's what goes in. So I'm going to have, well, there's an x there, so that x becomes x squared minus 9 minus 3. And finally, simplify, collect like terms. Now when saying simplify, you know, there's many different things to simplification, which is obviously, you know, like expanding with distribution, foiling, the whole 9 yards. But in this case, there's not much to do here. You just have the x squared minus 9 minus 3, so that's minus 12. And you're done. All right, now for part C, it's a little bit more involved. You're going to have f of g of 5. Well, g of 5, that's going to be 5 minus 3, because remember, whatever my x is becomes that number. Remember, this is a turducken here, my functional turducken. Copyright pending. So you've got f, 5 minus 3 is 2. So what am I actually substituting in? Just the 2. So put in a 2. It gets squared. Then you subtract 9 from it. So I've got 4 minus 9, which is negative 5. And that's it. As you can see, we just follow our steps 1, 2, 3, and you always get it done. So let's evaluate in example 3 the same kind of stuff. So we're still going to do f of g of x. Still going to do g of f of x. This is pretty standard in these kind of questions. So let's do these two first. So once again, what I'm actually substituting in. So f square root of x minus 1 is equal to, wherever I see an x, that now becomes x minus square root of x minus 1, so this becomes square root of x minus 1 squared plus 1 is equal to, well, square root, and it's being squared. That means the square goes away. All right. And if the square goes away, it becomes a normal, everyday thing. You get rid of the roof. Plus 1, which is equal to x. Beautiful, beautiful thing. All right? Then you got g. G of f of x, well, you've got x squared plus 1 is my f of x is equal to, well, where do I see an x? Well, I see a square root first, then I see the x, so that x becomes x squared plus 1, and then you subtract 1. All right, and inside my square root, I'm going to have x squared plus 1 minus 1, which is just square root of x squared, and square root of x squared is x. Now, one thing you have to be careful of. Does this x, this new function I made, does it have all values available to it? Because, you know, x is just a straight line. Boom, like that. Well, my original function, x minus 1, which is under a square root, have you ever been able to take the square root of a negative number? No, you haven't. So, its domain would have a restriction here, and that restriction would be x cannot be, well, x can't be it can't be lower than 1, basically. All right? So x has to be greater than or equal to 1. Same thing here. X has to be greater than or equal to 1 here. All right, so just keep that in mind. All right, last example. Let's use a number. Let's see how this works when we use a number. So I'm going to use the same number we used before. Let's use 5. So f of g of 5. Once again, you're going to do the same process all over again. F inside, this should become second nature at this point. I'm going to put the 5 in for my x in the g. So put the square root. And instead of x, I'm going to have 5. So my rational turducken here. Copyright incoming. Minus 1. All right, so that's going to give me f of, well, 5 minus 1 is 4. Square root of 4 is 2. So what am I actually substituting in? Just a 2. So x squared plus 1, that x is going to become 2. It's going to get squared. Then I'm going to add a 1 to it. 2 squared is 4, plus 1 is 5. And that's it. I hope that you have enjoyed and understood all these concepts. Have yourselves a wonderful day. Rational turduckens, substitution turduckens, incoming, copyright, prescription. I'm going to stop talking. Have a good day.